Alcohol is a colorless, limpid, volatile, flammable, water-miscible liquid. Its chemical formula is C2H5OH. It has an ether-like odor and a pungent, burning taste. The history of alcohol begins around 6000 BC, where grapevines were first being cultivated in the mountains between the Black and Caspian Seas, solely for the purpose of creating wine. The next important civilization to utilize wine was Egypt around 3000 BC. Wine production and shipping throughout the Mediterranean grew greatly because the Egyptians used wine. And the Romans and the Greeks even created a god of wine, Dionysus. Because of this, alcoholism became a problem in Greek and Roman societies. By 800 BC, barley and rice beers began to be produced in India. Between 500 and 300 BC, the Hebrews of the Middle East, mainly Israel, adopted wine as a beverage for all classes and ages. Some societies outlawed the drinking of alcohol, such as the Buddhist and Hindu religions. The history of alcohol as a fuel began in 1826 when Samuel Morey developed an engine that ran on ethanol. In 1876, Otto Cycle created the first combustion engine, and it was designed to use ethanol and gasoline. In 1908, the first Ford automobile, Henry Ford Model T, ran on pure ethanol, or a combination of ethanol and gasoline. Alcohol can be produced in one of three ways. The first way is that it can be produced by yeast fermentation of certain carbohydrates, such as grains, molasses, starches, or sugars. It can also be obtained synthetically by hydration of ethylene. Finally, it can be created as a byproduct of certain hydrocarbon syntheses. Alcohol has many chemical and physical properties. Its physical state is liquid. It has a pleasant odor that resembles that of a mixture of ethanol and acetone. It has a slightly bitter taste. Its molecular weight is 60.1 grams per mole. It is colorless. Its boiling point is 82.5 degrees Celsius or 180.5 degrees Fahrenheit. Its melting point is negative 88.5 degrees Celsius or negative 127.3 degrees Fahrenheit. Its critical temperature is 235 degrees Celsius or 455 degrees Fahrenheit. It is soluble in almost every liquid, very easily soluble. Okay, so we'll be learning about nomenclature rules for alcohol. When diagramming alcohol molecules, it's diagrammed so that R, which is the carbon molecules, is attached to the OH, the alcohol molecules, by a dash. Okay, so for an example of nomenclature in alcohol, we will be using pentane, which has 5 carbon molecules and 1 alcohol molecule. The next step to find out how to name this molecule is to number the carbon molecules from starting with the closest side to the alcohol molecule, which in this case is the right side. Number the carbon molecules 1 through 5. So the far right would be 1, then 2, then 3, then 4, then 5, being the one furthest to the left. Because the alcohol molecule is attached to the carbon molecule number 2, we place 2 in front of the word pentane as we name this molecule. In every alcohol you name, you always place the E on the end of the compound with an OL. So the final name for this compound would be 2-pentanol. 5 examples of alcoholic compounds are methanol, which is CH3OH. The second example is ethanol, which is CH3CH2OH. There is propanol, which is CH3CH2CH2OH. OH. There is butanol, which is CH3, CH2, CH2OH. And there is pentanol, CH3, CH2, 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 CH2OH. Alcohol, specifically ethanol, is used in the creation of alcoholic beverages. As a matter of fact, the alcohol that's found in every alcoholic beverage is in fact ethanol. Alcohol, once again, specifically ethanol, can also be used as a solvent. It can be used as a solvent as it is not harmful and it can dissolve chemicals that cannot be dissolved in water. Two types of alcohol, ethanol and methanol, can both be used as fossil fuel alternatives because they burn clean and they only produce water and CO2. Finally, alcohol is an excellent preservative. It is mostly used in the preservation of specimens. There are many reasons why there are so many new carbon-based molecules named every year. There are two major reasons. The first reason why there are so many different carbon molecules are because there are so many different combinations that carbons can be put into. This is because they have 4 valence electrons, so they can easily bond with many different elements, meaning that there are a nearly infinite amount of combinations of carbon-based molecules. The second and equally important reason is that carbon molecules can bond with each other to form long chains of carbons, leading to more carbon-based molecules. Thank you.